most of and any kind of virtualization you are running on your Linux or your Windows is a type 2 virtualization. So you have the metal, you have the hardware, sorry, you have the host operating system. Inside this operating system runs a particular process, which is the hypervisor, and this hypervisor hosts the guest OSs. What's the relation? No risk, no fun, buddy. Okay, isolation is a mechanism which is basically we want to run one kernel and have different user land parts of the OS. So basically, this is stronger than a CH root. Okay, if you use to Solaris zones or BSD jails, it's exactly that. We're gonna have a demo at the end of my presentation, having fun with the Linux version, Linux B servers. It's supposedly the next generation of virtualization. Let's see. So you have one kernel, and you can have different user land content in a way. Okay, so it's like CH rooting in a much stronger way in different environments. So a given Linux kernel can be running, for instance, one instance of Fedora and one instance of Debian plus one instance of Ubuntu, whatever. And only the kernel is shared among them. Okay, now we're going to do what I believe is really the most important part of hacking, which is surface analysis. Even when we go fuzzing, the best way to find bugs is actually to spend time on the attack surface analysis. I think Laurent will agree with me, right? The attack surface analysis is the core of it, where you spend more time. And if you manage to find an area that is being less studied or less audited, the chances that you will find a bug are much higher. So the first kind of vulnerabilities we can imagine regarding virtualization is privilege escalation on the host itself. So let's say you have a shell on the host, and you want to get root. Typically what happens is you're using some kind of driver bug in the core of the hypervisor itself. Okay, most of them have drivers. We'll get back to that later. And by exploiting such a vulnerability, you can get privilege escalation. So one example of this is this identity bug, which for some reason has no CVE. Another one which is less frequent is a privilege escalation on the guest operating system. This particular bug is particularly awesome because it's using really low-level tricks. It has to do with virtual mode, so the rest of my talk. What happened is that, in a nutshell, when VMware is trying to emulate a switch to virtual mode, it's running in ring 0, so it's running in kernel mode. And since the addressing in protected mode and virtual mode are different, one is using 16 bits registers, so a 20-bit addressing. Okay, you have a segment selector and an offset. You add virtually 4 zeros at the end of the segment selector. You add the offset, and it gives you a 20-byte 20-bit selector, 20-bit address, as opposed to real mode, which is running a 32-bit address. So what happened is that the fault handler in the virtual machine emulator of the virtual mode confused both of the addressing, and by using two different bugs, they actually managed to get ring 0 code executed inside the guest. Another thing we can do is if we have several virtual machines running side by side, okay, on the same hypervisor, we can try from one guest to attack another guest. So a funny one was the clipboard lack of isolation in VMware. Another thing you can do is try to simply perform a denial of service. So if you manage to have a denial of service on the host, obviously the guests are going to be affected since they are running very much as part of the host operating system. So typically by triggering several DLCTL from inside the guest, it's sometimes possible to trigger a fault that is so bad in the hypervisor that you're going to do the whole operating system. No, the real ground, the real thing we want is from inside the guest to get access to the host. This was shown by Raphael. It was shown as possible by Raphael with exam at Black Hat 2008. He had a kernel which was running, which had SLNX patches. It was basically a modern Red Hat. And from the guest, I mean, from a shell inside a guest, he managed to get a root shell outside the guest. Another example, which is less low level, is this iDefense one. Basically, you usually have some type of communication between the guest and the host to share files, to whatever. Sometimes it's using what we call hypercalls, which can be either privileged syscalls or even there are what we really call hypercalls are new instructions inside AMD and Intel CPUs. What happened here was very simple, much simpler actually. It was a directory transversal using some type of word encoding in the path of the shared folder from inside.